How does an exhaust gas recirculation valve work? On a gasoline engine, when the temperature of the combustion chamber approaches 2,500 degrees Fahrenheit, nitrous oxide emissions increase. The fuel-air mixture can also spontaneously combust, causing valve clatter and damaging the engine. Allowing a small amount of exhaust gas back into the intake reduces combustion chamber temperature. Regulating the flow of exhaust gas is the job of the exhaust gas recirculation system. Exhaust gas recirculation stands for exhaust gas recycle. The most basic form of exhaust gas recirculation would be a hole between the exhaust and intake manifolds. In the early 1970s, exhaust gas recirculation systems were little more. It was soon discovered that too much exhaust gas recirculation or applying it at the wrong time creates problems. Over the years, hundreds of exhaust gas recirculation designs have been developed. Every design attempts to serve the same purpose, regulating exhaust flow. Most early exhaust gas recirculation valves were vacuum-operated. A vacuum diaphragm opened and closed the valve, allowing and cutting off exhaust flow. An early refinement was a temperature-controlled shutoff in the vacuum source. This kept the exhaust gas recirculation valve from opening when the engine was too cool. The cool engine did not require exhaust gas recirculation, and cutting it off made the engine run smoother. Exhaust gas recirculation flow is also undesirable at other times, for instance at idle. At very low speed, combustion temperature is naturally lower. Adding exhaust gas at low speed can cause rough idle. The positive back pressure exhaust gas recirculation valve helped solve this problem. Similar to a standard vacuum model, the positive back pressure design has a hollow valve stem. This allows exhaust gas pressure to push against a spring-loaded vacuum valve. When back pressure rises, such as on acceleration, exhaust pressure closes the spring valve and seals the vacuum opening. This allows an engine vacuum to open the exhaust gas recirculation valve. When back pressure is low, such as at an idle, the spring opens the vacuum port. Engine vacuum is bled off and the exhaust gas recirculation valve closes. The design change has caused many good exhaust gas recirculation valves to be replaced needlessly. Vacuum-operated valves are often tested by applying vacuum to see if the valve opens. If the valve does not open or if the vacuum cannot be held, the valve is considered bad. This works okay on a standard or on a negative back pressure exhaust gas recirculation valve. A positive back pressure valve will not hold a vacuum or operate without positive back pressure. Testing this valve by that method will give false results. The positive back pressure valve would have to be tested with the engine speed raised to around 2000 rpm. Creating positive back pressure. Exhaust gas recirculation valves on modern vehicles are controlled by the engine computer as an output, using several sensors as inputs. Ford uses a differential pressure feedback exhaust gas recirculation or DFI sensor. This monitors exhaust back pressure before and after the valve. By comparing the two, exhaust gas recirculation flow can be more precisely calculated. The vacuum source is regulated to open and close the exhaust gas recirculation valve and control exhaust flow. Electrically operated exhaust gas recirculation valves are also common. These may have up to 3 valves in one unit. The engine computer can open and close any or all the valves in response to input from sensors. For instance, the electronic temperature control or etc. sensor informs the computer when the engine is cold. NOx sensor signal valve clatter or detonation. A sensor built into the unit informs the computer of the position of each valve. Problems with exhaust gas recirculation. Because exhaust gas contains carbon, the passages through which it flows are prone to stopping up. When this happens, the flow is interrupted. On post-1996 vehicles, this will set a diagnostic trouble code or DTC and the check engine light will come on. These codes are very often misdiagnosed as a bad exhaust gas recirculation valve. Many engines have multiple exhaust gas recirculation ports for discharging exhaust into the intake. If several ports plug up, all flow can be directed to a single cylinder. This can cause a misfire, which is very often misdiagnosed. Countless injection flushes and tune-ups are needlessly sold for this problem, without success. Removing the intake and clearing the passages are the only repair. The carbon in the exhaust gas can also coat the throttle body plate. When this happens, rough idle and dying can occur. The engine may set a general misfire code, which is often misdiagnosed. Cleaning the throttle body will generally clear the problem. Actual failure of the exhaust gas recirculation valve is rare. An exhaust gas recirculation valve can stick open when it should not, causing a rough idle or hesitation. It can also stick closed, causing valve clatter and a check engine light. Far more common are failures of the sensors that read and monitor the flow or the hoses and wires that control the system. An exhaust gas recirculation code needs to be properly diagnosed to learn the cause. Replacing parts without understanding how the system operates can be a very expensive lesson in swaptronics.